Okay, the respected officers, SSC, Gs, and all the SNT staff who have joined this webinar, I welcome you all in this webinar on SSBPAC, that is Solid State Block Proving by Axle Counter Digital. So actually on this topic, we have conducted we have conducted a webinar in the January 2022. But now Camtech has taken up a project on preparing a maintenance manual on SSBPAC with the help of Messrs. Efftronics. So today we have with us Mr. Srihari from Messrs. Efftronics Systems Private Limited, Guntur. He will be giving the presentation on SSBPAC. So I welcome him also. And Mr. Srihari, can you hear my voice?
Yeah, I am hearing you, sir. Am I audible to you?
Yes.
Yeah.
So without wasting much time, I request Mr. Srihari to start his presentation. Thanks.
My presentation is visible now, sir. I'm sharing my screen now.
Yes, it is visible.
Yeah. Okay, sir. Thank you very much. Yeah, good afternoon, everybody. And my name is Srihari, and I have been with Efftronics for the last 12 years, and I've been in different roles. And currently, I'm working as senior manager. I have presented technical papers on different platforms on monitoring and controlling of signaling systems. Today, I'm going to talk about SSBPAC digital, short for solid state block proving by axle counter, which is an electronic block instrument. Yeah, solid state block proving by axle counter is an electronic block instrument. It has been developed as per RDSO specification 175/2005. Right now, Efftronics is the only approved vendor for this equipment. So in this session, we are going to discuss about what is this equipment, its features, hardware and subsystems, how these subsystems...
It's not coming.
Is it not coming? Hello?
Yes, it is coming, sir.
Yeah, thank you. If there is any problem with my eyes, you can please tell us. Thank you. Yeah, in this session, we are going to discuss about what is this equipment, its features, hardware and subsystems.
Feature
Please, sir, कोई problem?
Speech வருது சார்.
நல்லா ரவி நல்லா வருது ரவி.
Yeah, Pravir sir, can I continue or is there
yes, please continue.
Yeah, thank you. So in this session, we are going to talk about this block instrument, its features, hardware and subsystems, its inputs and outputs, block operations, how all these subsystems are interconnected, the schemes of power supply, communication and surge protection, how this instrument is interfaced with the station signaling, and at last we are going to look at the difference between this block instrument and UFSBI. So these are the things I'm going to cover today. So we all know that this is an electronic block instrument used to control the coordinated movement of train in the block section, working on absolute block working principles. Before we move on, we just have a look at the basic difference between this block instrument and SSDAC, SSDAC. SSDAC is a digital axle counter which is used for proving clearance of block section. Whereas SSBPAC is an electronic block instrument. It takes one input from axle counter along with other inputs from station signaling. So it is kind of first block instrument on Indian Railways. Only interface relays are used for input and output, and block logic is achieved through a software. So this is the basic difference. One is axle counter and one is electronic block instrument, which takes one input from axle counter. That's it, along with other inputs, other signaling inputs. So just I'm showing you the population. Around 380 pairs have been supplied. As of today, 160 block sections have been commissioned. And installation is in progress at 105 block sections. So block section commissions division wise is shown here. Single line 120 single line block sections have been commissioned and 40 double line block sections have already been commissioned out of those 160. So division wise also we can see here. Let us talk about the features of this block instrument. It is of push button type and non-cooperative, and the safety standard is safety integrity level 4. For interblock communication, variety of mediums can be interfaced to this block instrument like conventional copper cable or a dark fiber, even channel of OFC or a voice channel of OFC. For block telephone, one pair of copper cable or one voice channel are required. So let us look at those features in detail. Like I have already covered the type and communication mediums, and transmission loss permitted between two instruments is 30 dB at 1 kHz. Data speed is 9600 bits per second between two instruments. Single power supply of 24 volts DC is sufficient for main units and its auxiliary systems. The current consumption is about 3 amperes at 24 volts DC. Remote condition monitoring of this block instrument is possible. Means this block instrument can be monitored from a central place. This is possible by networking this block instrument to existing data logger provided in the station. All the internal data or all the operations can be transferred to a central place through an existing data logger where the data of block instrument can be analyzed and reports can be generated. So this type of analysis is helpful in case if there is a failure in the block instrument. The processor architecture, that means the architecture adapted in design of this block instrument is 2 out of 3 architecture. Means there are 3 CPUs in the system. 2 out of 3 architecture is adapted to provide the maximum safety and availability of the system. The output cards or the output relays are driven only when any of the two outputs of 3 CPUs are equal. Means only 2 CPUs shall produce the same output. At least 2 CPUs shall produce the same output to drive the output cards. In this way, it ensures safety. At the same time, if any one CPU card or one input card fails, the system will continue working on 2 out of 2 mode. Hence, this will give the maximum availability of the system. So single CPU card failure or an input card failure will not cause the equipment to fail or a block to fail. So it fits for both RE and non-RE. Same instrument can be used for both RE and non-RE without any modifications. Two separate block instruments for single line and double line. There is permanent section ID is etched on the motherboard of this block instrument. This provides additional safety so that by etching this section ID permanently on the motherboards of this block instrument, that particular block instrument will only communicate with its pair only, so that it will not communicate with any other block instrument which is not in its pair. Apart from this section ID, there are self system ID and remote system ID that are configured while commissioning of the system. There are two repeater relays in the system which are used to repeat status of a relay from one station to another station. So that is all about the features, major features of the system. Now moving down to the hardware of this block instrument. Hardware can be divided into two parts. One is main units and second is subsidiary systems. So these are the two main units of the system. One is equipment rack and the second is block panel. In the equipment rack, there are two other racks inside the equipment rack. The first one is Euro rack, in which all electronic modular cards are provided. So the bottom of the Euro rack, there is a relay rack. This relay rack houses for all interface relays, that means input and output relays. The second main unit is block panel. This block panel is provided in the station master room for block operations. So it is a man-machine interface, this block panel. So these are the two main units of block instrument. So of course the same is given here. Apart from those two main units, there are three subsidiary systems or auxiliary systems. The first one is GPS receiver. This GPS receiver is used to synchronize the three CPUs time with the GPS. So all three CPUs are synchronized to GPS through this GPS receiver. And there is a 2 out of 3 buzzer, as we know that there are 3 CPUs and 3 input cards in the system. This 2 out of 3 buzzer is activated in case if there is a failure of a CPU card or an input card. If any CPU card or input card fails, this 2 out of 3 is activated, and this unit will alert the station master by giving audio visual alarm regarding the failure, so that the station master can alert the available maintainer. And the third of the subsidiary system is user terminal or a maintainer terminal. Through this maintainer terminal, one can see the status of block instrument, block section status, block communication status, status of input relays and output relays, status of buttons, keys, doors, and errors also, error codes. In case of failure, system generates errors, and those error codes also can be seen through this maintainer terminal. So these three are subsidiary systems.
Sir.
Hello. So let us see the location of these subsidiary signals, subsidiary systems. The first one is GPS module. This is provided on the wall just behind the equipment rack.
Sir, please, all are requested to mute their mics. Sir, somebody's mic is unmute.
Yeah, thank you. So the GPS module, that is GPS receiver, is just located behind the equipment rack, on the top of the equipment rack on the wall. And 2 out of 3 buzzer is provided on the top of the block panel near to station master. And maintainer terminal is generally provided in maintainer's room. So these are the 3 locations. One is in maintainer room, the maintainer terminal, GPS module near the equipment rack, and the third is 2 out of 3 buzzer unit on the top of the block panel. The first part of the equipment rack, that is Euro rack. In the Euro rack, there are 11 PCBs. In those 11 PCBs, 3 are input cards, 3 CPU cards, 1 voter card, and there are 2 output cards. One is vital module and the second is non-vital module. And there is a communication card one, and of course automatic communication changeover unit. It can also be called as media changeover unit, automatic communication changeover unit, or media changeover unit. These are the 11 PCBs that are provided in the equipment Euro rack. So this is the front view of the Euro rack, in which all the electronic modular cards are provided. The leftmost of these cards, that is ACCU module, automatic communication changeover unit, is provided here. It connects between any two mediums, but particularly here this ACCU can be connected between a voice channel and an even channel. So for maximum availability, it is always preferred to go for two different mediums, like one voice and one even, or one voice and a fiber, or one fiber and a even, or if there is a path diversity, two fibers can also be connected. So this is a media changeover unit, and this media changeover unit is interfaced to available media for interblock communication. And the second card is communication module. So this communication module is used for connecting local data logger, user terminal, 2 out of 3 buzzer unit, and if local PC is available, that can also be connected. Apart from this, this communication module will also have redundant DC-DC converters on it. So these DC-DC converters will provide power supply to media changeover unit as well as to voter card and two output modules. So communication module provides power supply to media changeover, voter module and output modules. And third one is input module A followed by its CPU. So input module A and CPU A are one set, input module B and CPU B second set, input module C and CPU C, that is third set. CPU module has its own power supply mounted on it. The CPU card will provide power supply to its spare input module. This input module takes inputs from a scrambler card, and also it displays the status of those inputs, whether they are pick up or drop, that status, and it transfers those inputs to a CPU module. CPU module processes those inputs and it produces the output to voter module. Here we can see on the CPU module, we can see the this CPU also monitors its power supply, own power supply, whether it is within the range or beyond the range. Like if it falls below 4.5 or if it is above 5.3, these LEDs will blink. So these 7 segment digits are to display error codes. In case of any failure, these CPU cards will display error codes. So the IPC means inter-processor communication, IBC means inter-block communication, and the status of this processor, whether it is running or not. So this is all about a CPU module. Similarly, input B and CPU B, input C and CPU C, these modules also will process the inputs and produce the output to a voter module. This voter module compares the output of or evaluates the output of 3 CPUs and produces the output or drives output cards only when at least 2 outputs of 3 CPUs is equal. Means this actually doing the function of 2 out of 3 architecture. It is comparing the output of 3 CPUs and drives output cards only when at least 2 CPUs outputs are equal. Means whether A equal to B or B CPU equal to CPU C or CPU C equal to CPU A, and it is just comparing the outputs of CPUs. The first card, output card, that is non-vital output module, is used for driving indications on the block panel. It is just for indicating driving indications on block panel, and apart from that it also drives critical power control relays or internal system relays CPC1 and CPC2. So the function of non-vital output card module is to drive non-vital indications on the block panel and driving CPC relays. The last card or the rightmost card is vital output module. It is used for driving vital output relays like TGT relay and its release coil. The final output relay, that is advanced order control relay ASCR, and TCF and its release coil, and shunting relay, and of course 2 repeater relays. So these are the relays that are driven by the vital output module. So this is all about the 11 PCBs. So total there are 11 PCBs in the Eurorack. The same is given for further study of this material. So input cards, CPU cards, input cards are 3, CPU are 3, and water card is 1. There are 2 output cards, 1 communication card and 1 automatic communication changeover unit. So there are total 11 PCBs here. So the bottom of Euro rack is, there is a relay rack. In this relay rack, it houses for all the interface relays, that means input and output relays. So there are total 13 relays. So there are total 13 relays in the system, plugged on 11 bases. Out of those 13 relays, 6 are input relays to the system and 3 are output of the system. So 6 are input relays to the system and 3 are output of the system. There are 4 other purpose relays that I will cover. There are 4 other purpose relays, and total there are 13 relays in the system mounted on 11 bases. The left of the screen, the relay rack is shown on the left of the screen when relays are not plugged in it. So there are total 11 bases, as we can see here. On these 11 bases, 13 relays are mounted or plugged in. On the right of the screen, we can see relays, the relay rack when relays are plugged in. So on the top of the relays, the right of the screen, we can see a global reset button or a globe with a counter. So global reset button with a counter. So this global reset button is used when to bring the function into system when the system is initially powered on, or when any card or any relay is replaced. So this global reset button, we have to apply global reset to bring the system into function when we initially power on the system, or when you replace any card or any relay, we have to apply this global reset to bring the system into function. Again, accordingly, the counter in the reset button, will get incremented. So there is a power on switch, that is MCB, provided here for turning on and turning off the system. This is the rear view of the system or back view of the system. The left of the screen is the left side view of the system. So all these relays, the back view of the relays, the wiring we can see here. On the top of the screen, we can see a card. This is called scrambler card. I will explain about this later. This is called scrambler card. To this, all the inputs are given. Inputs from station signaling, inputs from block panel, readback inputs, and the global reset button inputs. All are given as input, are wired to this global reset, this scrambler card. And through this scrambler card, the inputs are further extended to input cards through ribbons. The left of the screen, we can see there are terminal blocks, C1, C2, C3, and these are the terminal blocks used for terminating cables or terminating wires from block panel, wires from station signaling, wires from a data logger for monitoring purpose. So all these cables are terminated here on terminal blocks. Similarly, these C4, C5, C6, C7 also, they are also for wiring station inputs or block panel inputs, or wiring to data logger for monitoring purpose. So total there are 7 Vagos that are visible here for wiring purpose.
Sir, one question.
Uh-huh.
So, which base accommodates 2 relays? Actually, there are 11 bases and 13 relays, na?
Yeah. Two relays are there. QN N1 relays are there. Twin relays. 2 bases. I will show them.
Okay.
So as I said, there are 6 relays, 6 input relays to the system. These are those 6 input relays. The first one is input from axial counter, just I said in the starting. So that is BPAC relay, one input from axial counter. And for single line, we use shunt KR relay for permit the shunting. to enable the shunting. This is only available in single line. For double line, in place of this relay, BPSC relay, second BPSC relay will come, dispatch and reception. And the third input relay is ASGNCR, and it picks up when advanced order status and its controls are normal. And similarly, home signal GNCR, it picks up when all reception signals status and its controls are normal. And two sequential track circuits after home signal, that means home signal AT and home signal BT, these two track circuits are wired as input to the block instrument. So these are 6 inputs to the system. The type of relays used here are shown. So QNA1, as we are using these same block instrument in our area, so we are using immunized relays here. QNA1 of type 8F, 8B, all these are same relays. Their normal status is up, and of course how they are operate, how they operate is given here. Yeah, 6 input relays and their type and status are given here. So there are 3 output relays, and they are TGT, picks up when line clear is obtained, TCF picks up when line clear is granted, and the final output relay, that is advanced order control relay, picks up when line clear is available and LSS control is reversed. So these two are different type. They are latching relays QL1 of 11F4B and 11F4B. These are used to hold on to the same state even the power supply is removed. So these two are the only different relays, QL1 and QL11F4B type. And of course, ASCR, since it is an internal relay, only QN1 is used. So total 3 outputs and 6 inputs. Apart from these 9 relays, there are 4 more relays. They are of QNN1 type. These two are mounted on the same base. So only one base is required for these two relays. They are 4F4B type and 4F4B. So these are critical power control relays CPC1, critical power control relay to CPC2, and the type is QNN1. Their normal status is if one relay is in up and the other relay is down. One relay picks up at every 30 minutes and the other relay drops. These two relays will check the integrity of the entire system, and if there is any problem or if there is any failure, these two relays will shut down the system safely. So there will not be any unsafe side failure from the system. So as I said, there are 2 repeater relays, repeater 1 and repeater 2. They are also same type QNN1, and their normal status is down. And these 2 relays can be used to repeat the status from one station to another station based on the wiring of the contact. So this is about input and output relays of the system, and the 6 input relays of type all are QNA1 and 8F8B, and 3 output relays. 2 are latching relays in those output relays, and 1 is normal neutral relay. So 4 other relays are there for watchdog, and they are critical power control relays. 2 critical power control relays. 1 picks up if other is down. Repeater relays are 2. The second main part of this block instrument is block panel. This block panel is used for man-machine interface, and it is used for operations. It is very similar to that of UFSBI that we are using. This block panel is for single line. There is not much difference between single line and double line as far as operations are concerned. So on this single line, we have 2 keys, that is the station master key and the shunt release key. We have 2 keys on the panel, and of course we have 5 buttons on the same panel. So total there are 5 buttons and 2 keys. This SM key is for ensuring only the authorized person is operating the panel. And shunt release key permits shunting, it enables shunting. And second point is it can be used for blocking line clear. So it prevents other station master from taking line clear if you keep this shunt release key in. Shunt release key in prevents other station master from taking line clear, or it blocks line clear. At the same time, shunt release key in enables shunting at the same station. So train going to is used for getting line clear. Cancel cooperation button is used for sending cooperation during a cancellation. And cancel button is used for cancelling line clear. And of course, if you cancel a line clear, cancel counter gets incremented. And bell button is used for sending attention, sending bell codes to the other station. At the same time, this bell button is used for taking line clear, or used when you cancel a line clear. So acknowledgement button is simply used for acknowledging the operations, or train entry into the block section, or train exit in the block section. So just for acknowledging those operations or movements. So just the purpose of those buttons is again given here. The purpose of all buttons and keys. So block panel double line, it is quite similar to that of single line, except there is a change in here. Here in place of shunt release key, there is only one change. Line clear blocking relay will be used here instead of shunt release key. So this LCB key is used for blocking line clear. So this LCB key prevents line clear from other station master. So one more change here is we have two acknowledgement buttons here. As we have two different lines for train movements here, we have two acknowledgement buttons. Remaining all buttons and keys have same operation here. So here we right off the screen, we can see here SSBPAC its status OK and fail. We can see here, and communication status, the interblock communication status is shown here by indications. Of course, signal normal indication of the station, axle counter indication, a signal normal indication, and a signal normal status of other end, and of course axle counter and the status of block. All this we can see. Of course, LSS indication is shown here. So that's again the purpose and buttons and keys of double line block panel is given here. So what block operations are done by using this block panel? Block operations can be said in two types, or block operations can be divided into two. First, taking line clear is one operation, and second, taking advanced order off. For taking line clear request operation is sent to this block instrument as input, as a command, and this command or this request is sent to the other station or other end block instrument. If all conditions are met, if all conditions are satisfied, TCF relay of other end block instrument picks up, and that enables TGT relay of sending station picks up. So TGT picks up indicates that line clear has been obtained, and TCF at the other station indicates line clear has been granted. So once line clear is received, or once line clear is obtained, station master operates advanced starter by operating advanced starter RR, and that will go as input to the block instrument. That is, advanced starter RR input is given as a request is sent to the block instrument, and by receiving advanced starter RR, if already line clear is obtained, block instrument will pick up its final output relay, that is advanced starter control relay. So for obtaining line clear, TGT picks up. For clearing advanced starter, ASCR picks up. These ASCR contacts, the contacts of this ASCR relay are used in the LSS DR control circuit. So the two front contacts of ASCR are used in the ASDR circuit, and by this the advanced starter gets cleared. So block operations are two. One is getting line clear and the second is clearing advanced starter. There are 7 conditions for getting line clear. There are 7 conditions for getting line clear. So the first point is SM key must be in at sending station. TGT and bell buttons are pressed by the sending master. Shunting key in case of single line, shunting key must be in at train's receiving station. Block section clear. Before taking line clear, both block instruments should be in line close state. Reception and dispatch signals at both stations shall be normal. 2 track circuit after home signal HS80 and home signal BT at both stations are clear. So these 7 conditions shall be fulfilled or shall be satisfied before getting the line clear. Similarly, for closing a line after receiving a train, these 4 conditions have to be met or have to be satisfied. The first is home signal control is reversed at the receiving station, and both track circuits, home ATPR and home BTPR, 2 track circuits after home signal, they are occupied and they are cleared in sequence, proving train movement. Reception and dispatch signals again at both stations normal after operation. Block section is clear. So these 4 conditions will close the line if they are satisfied. So again, what we discussed now is given here. The activity is done by the sending station master for getting a line clear. Activity is done by receiving station master for granting a line clear. And what response is given by SSBPAC when it receives commands or inputs from block panel is given here. So taking line clear and clearance of LSS, these two are the operations for sending a train. So there is one more operation. The second operation is line clear cancellation. For line clear cancellation, cancel cooperation button and bell button are pressed, and at receiving station cancel and bell buttons are pushed, and after 2 minutes TGTR at sending station and a TCF at receiving station will drop and line will be closed.
So in the first case, that take out shunt release key, why it is given?
Yeah, shunt release key, this one, sir, I will show you.
Yes.
Yeah, this is shunt release key. This has to be out. If it is in, means we are doing shunting here at the sending station, so that will not allow line clear, or that will block line clear. So this shunt release key shall be out for single line. SM key must be in and shunt release key should be out. If it is in, means it enables shunting of a train in the same station, within the station. So it must be out for getting a line clear.
No, it is only to be, it is only turned, or
Yeah, it is just a key. Yeah, it is turned or turned in. That is.
it is taken out or only turned in and out?
Yeah, it is. Yeah, it is just turned out. Even if you take it out, no issue. But it can be keep like that, no issue.
Okay.
It can be kept like that. Yes, sir.
Okay.
Yeah. Yeah, the key can be kept like this if it is an out. This one.
Yes. Okay. Clear.
Yeah, after block operations and just we have seen, I would like to discuss about the inputs and outputs of the system. What inputs are given as inputs, or what are given as inputs to the system, and what outputs are generated by the block instrument. Both front and back contacts of all block panel buttons keys are given as input, and both front and back contacts of signaling system are given as inputs, and output relays readback is also given as input, and health relays and global reset contacts are also wired as inputs. Total 47 inputs are wired as inputs to the block instrument. So these are those inputs. From block panel, 13 inputs are wired. From signaling system of station, 16 inputs are wired. and there are 12 readback inputs of output relays. And health relays, like what I said, CPC1, critical power control relay, and control relay 2, and global reset button. So total 47 contacts or 47 inputs are wired as input to the scrambler card. This scrambler card, what does it do is, this scrambler card divides each input into 3 outputs, and it applies 3 inputs at different numbers or different places on input cards. We can see here the input number 1 is applied at input number 12 in input card A. The same input is applied at input card number 23, and the same is applied at number 34 in input card C. The reason for doing like this is reason for scrambling like this is to avoid common mode failures. So just we are scrambling or jumbling the inputs here. The same input is applied at different places in the 3 cards. Similarly, the input number 2 is divided into 3, and the input may be applied at 3 different places or different numbers in 3 input cards. These 3 input cards will process the input and they produce the output to CPU cards. 3 CPU cards will process the data or process the commands or inputs, and they produce the data to water cards. So total we are giving inputs from 4 areas. One is station master block panel inputs by operating the panel, and second is signaling system inputs, they are interface relays, and third is output relays, the outputs generated by the system, they are wired as input as a readback relays, and status of health relays and status of global reset. So all these inputs are wired, all these status contacts are wired as input to scrambler card. So again, as I said, a total 47 inputs from station signaling and its own subsystems are wired as inputs to the block instrument. Both NO means front and back contacts of all buttons and keys are wired. Similarly, station signaling inputs are also wired. Both front and back contacts are red. So by processing those 47 inputs, CPU generates outputs. So these are the outputs delivered by the block instrument. CPU produces the output to water card. So this water card compares the output or evaluates the output of 3 CPUs. CPU A output, CPU B, and CPU C. It checks that whether CPU A is equal to CPU B, CPU B is equal to CPU C. Similarly, CPU C is equal to CPU A or not. And it drives the output cards like vital output and non-vital output only when any 2 outputs of 3 CPUs is equal. This non-vital output card is used for driving indications on the block panel. At the same time, this non-vital card is used for picking up critical power control relays or health relays, we can say. Vital output card is used for driving vital relays like TGT, train going to, train coming from TCF, an advanced order control relay, and a shunt EKT in case of a single line, and of course repeater relays.
Excuse me,
Sir.
is this a non-vital output card and vital output card is at other station or at the same station?
No, at the same station. I will again going back, I will show you. So here you can see, sir, this is non-vital card. They are in the same station in the same Euro rack. So this is non-vital output module and this is vital output module of the same station, the same equipment, these two.
In specified Delta, is the driving output card at the other station. That's why.
Okay, sir. For this non-vital and output modules are in the same Euro rack for that station. Similarly, for other station, that will have its own non-vital module and vital output module. that is there.
Okay.
Yeah. So we have non-vital output card and vital. So non-vital card drives indications on the block panel, and vital output card drives final relays or vital output relays of the system. Again, for additional safety or at a second level safety, the output of all vital cards is again wired through the interface relays. As you can see here, to pick up a TGTR relay, the output of vital card is wired through GNCR relays, home signal GNCR, advanced order GNCR, shunting relay, AZTR, and TCFR. This is for single line. So again, for additional safety or a second level check, even physical relays are also considered before driving the output relay. So this is vital output card. This vital output card provides 24 volts or 24 volts pulse through a motherboard to the relay. So that power supply is taken through all these interface relays before picking up TGTR relay or before reaching TGT relay. So just I said, yeah, 8 outputs are there total vital outputs. They are like TGT and its release coil, advanced order control relay, TCF and its release coil, shunt EKT coil for single line, repeater 1 and a repeater 2. In case these two relays are used, in case user wants to repeat a relay from this station to another station. There are total 24 non-vital indications, non-vital outputs for indicating the status of block instrument on the block panel, like global reset indications, cancel indications. There are total 24 indications. These all 24 indications are driven by non-vital output card. So total 24 indications. This. So this will give us a idea when you look at the input and output in a same picture or a same diagram. So all station inputs are wired as input to the block instrument through a scrambler card. This scrambler card applies by scrambling them or by dividing the each input into 3, and it applies to input cards at different numbers. And these input cards provide the output to CPU, and the CPU's process and delivers the output to water. Water compares the outputs, 3 outputs, and if all conditions are okay, then this water card drives vital and non-vital output cards. Communication module is used for collecting data from CPUs. It is used for collecting data from CPUs, and it sends the data to other end SSBPAC through a media changeover unit or automatic communication changeover unit. So the data of these CPUs will be transferred to other station block instrument through communication module. And of course, this communication module is also used to interface with the station data logger and user interface PC, and power supply 24 volts DC power supply is taken for power supply. So this is the overall picture of the system, inputs and processing those inputs and producing the outputs, communication and power supply. So these are all 5, if you can take it as a 5 units: inputs, processing the inputs, producing the outputs, communication and power supply. Total 5. So inputs and outputs, as you can see, total 8 outputs are there, total 24 non-vital outputs, 47 inputs, 8 vital outputs and 24 non-vital outputs. And inputs are given, inputs are processed and outputs are delivered, and communication to other end block instrument and power supply. Now moving down to how all these subsystems are interconnected, or we can say it as a cabling scheme for interconnection. So when we look at this picture, we can see there are 8 portions in the picture. The first one is equipment rack. The first point, that is equipment rack. This is generally located within the relay room. If space and all are available, this is provided within the relay room. And the second important thing is block panel provided in the station master for block operations. And third is maintainer terminal. This maintainer terminal is used to access the data from this block instrument. Through this maintainer terminal, one can see the status of block section, card status, interface relays, block panel inputs, EKT, all those status can be seen through this maintainer terminal. And the fourth is 2 out of 3 buzzer. As I said, it is used to alert the station master in case if there is a failure in the system, it is activated. And a GPS module for time synchronization purpose of these 3 CPUs. We have 3 CPUs, and for time synchronization, GPS module is provided here. All the relays, buttons, keys, doors are wired to data logger for monitoring purpose. So all the relays and block panel buttons and its keys and doors of the block instrument are wired to the data logger for monitoring purpose. Apart from this, 3 CPUs generate diagnostic data, and all that diagnostic data is sent to a central place through this data logger. And next is relay rack for interfacing purpose, station signaling interfacing purpose. And there is a power and the point number 8 is IPS room. Power supply is taken from IPS. Now we look at the cables used between these subsystems. Underground signaling cable or outdoor signaling cable or jelly filled cable is used between block panel and equipment rack for giving inputs from block panel to equipment rack for exchanging communication between block panel and equipment rack. 40 core cable is used between block instrument and data logger for wiring all these relays, buttons and keys into data logger for monitoring purpose. Shielded cable is used between block instrument and data logger for sending its diagnostic data to central place through networked data logger. So there are 2 connections between data logger and block instrument. One is for monitoring relays and keys buttons, and the second is to receive the diagnostic data from block instrument and sending the diagnostic data to a central place. 16 into 0.2 square mm multi-core cable is used, or multi-strand cable is used between block instrument and the station relay rack for interfacing purpose. That means wiring input and output relays to the block instrument. Shielded cable is used between block instrument and GPS receiver for receiving GPS time from GPS. Again, shielded cable is used between maintainer terminal and block instrument for exchanging the data or for transmitting the data to this user terminal or maintainer terminal. 2-core power cable of 6 square mm is used between IPS and block instrument for power supply purpose. So for power supply purpose, 6 square mm 2-core cable, and for block operations or for wiring between block panel and equipment rack, underground signaling cable or jelly filled cable is used between these 2 units. Remaining Shielded cable is used between equipment and subsystems. And 16 into 0.2 multi-strand cable is used for interfacing purpose, wiring, station signaling, interface relays. And 40 core cable or a 60 core cable is used between block instrument and data logger for wiring relays. So this is all about wiring scheme or a cabling scheme, or how the subsystems are connected together. Again, the same information is given here. So from power panel to equipment, 6 square mm cable, block panel to equipment rack, underground or jelly filled cable, like station relay rack to equipment rack, 16 into 0.2 multi-core copper cable. So what type of cables are to be used for interconnection? Again, in detail given here and their purpose. So now power supply, what power supply is required for this block instrument? Single power supply of 24 volts DC is sufficient for all subsystems. Means no other power supply is required. Only 124 power supply with redundancy is required for all subsystems. Of course, the maximum load is 3.5 amperes at 24 volts DC. So the power supply from IPS is terminated on the SPD, and from SPD the power supply is taken to on off switch, as we see the switch that we saw, that is MCB. From MCB the power supply is extended to fuses, and from fuses the power supply is distributed to different subsystems. So main power supply is given, and that power supply is internally distributed to various submodules. So actually there are 6 fuses, but important or main fuses are only 5, and that is why fuse number 6 is not shown, and fuse number 6 is generally spare. Fuse number 1 is used for block panel power supply, and fuse number 2 is for Euro rack power supply. Fuse number 3 is for readback relay inputs, and fuse 4 is for field relay supply, and fuse 5 is for block telephone supply. Again, from IPS through a surge protection device, the power supply is applied to this block instrument. From here, through fuses, through power panel, the supplies are distributed and applied to different subsystems. Again, the purpose is again given here. Fuse number 1 for panel supply means block panel supply. Fuse number 2 is for Euro rack. Fuse number 3 for readback relays. Fuse number 4 is for field supply. Fuse number 5 is for block telephone supply. So after power supply, it is now we are at communication. So for inter-block communication, variety of mediums can be interfaced to this block instrument, as we discussed at the start of the session. So there are 4 types of mediums available. They are conventional copper communication cable, voice channels of OFC, even channels of OFC, and a pair of dark fibers. According to the medium or media, the media interface will be changed in the block instrument. If we have copper communication cable, we have to use voice modem. If we have voice channel of OFC, again we have to use the same voice modem. But if there is even channel, we have to provide even to port, even to serial converter. And if dark fibers are to be connected, media converter with a serial port to be used. All are available now. But for better availability, it is recommended to connect to 2 different mediums, so that single channel failure or same medium failure will not cause the block or equipment to fail or block system to fail. So to prove for improving the availability of block system, automatic communication changeover unit is provided. So again, it is a media changeover unit. So 6 types of mediums or 6 combinations can be connected to this automatic communication changeover unit. We can connect one voice, one even, or we can connect one voice or one media converter, means fiber. We can connect one even converter or one fiber. We can connect two voice modems. If there is no OSC, we can connect to two voice modems, or we can connect to two even, or if we have path diversity, we can connect to two media converters or two even converters if we have path diversity. So this is for interblock communication. This many combinations we can use.
Sir, this is a particular make ACCU.
No, sir. This is of our make only, OEM make.
Okay.
This is, yeah. Depending on the availability of communication medium at station, we can go for any of these.
Okay.
Yeah, thank you. For block telephone purpose, one pair of conventional copper cable or one voice channel is required. Nowadays, we are providing manual changeover of this for block telephone so that we can connect one voice channel and one copper communication cable. So that in case of one copper cable failure, the block telephone communication can be continued on voice channel and vice versa. Since it is an electronic system, there is always a prone for failures affected by surges and all. So to protect against surges, surge protection devices are provided for both power lines and communication lines. Means both power and communication or power and data lines are surge protected. So surge protection devices, they need to be connected to the station equipment room to the earth provided by railways. Ideally, the earth resistance shall be less than 2 ohms. So this is how surge protection is applied. Surge protection is provided for power supply. So 230 volt AC from IPS that is given to SPD, and from there to a switch MCB, and from there to loads, fused loads. And these are communication lines, and surge protection for data lines or communication lines. There are three-stage protection is there from communication equipment room. Isolation transformer is provided, and from there surge protection device is provided, and from there the communication lines are protected by GDT protection. This is a third stage protection, and before applying to our modem or our ACCU. So for communication, there are three-stage protection for a copper cable. So isolation, galvanic isolation is there, surge protection is there, and another level of surge protection. So before applying to the modem of SSBPAC or block instrument.
GDT means previous slide. EDT. Action. What is this, sir?
Yeah, GDT means it is actually gas discharge tube. It is also a type of surge protection device, SPD. It is
Okay. Okay. That's discharge.
So till now we have discussed about the block instrument, its inputs and outputs, block operations, uh, the subsystems and how they are interconnected. So all these things we have covered. Now we are just moving down to interface circuits, that is station interface circuits, or how this equipment is interfaced to station signaling, means station interface circuits input. It is very simple. Total 8 inputs are required from station signaling as input to the block instrument. Just we have seen already them. In case of single line, block axle counter 1 input will be given, and similarly if it is a double line, up and down lines axle counter inputs are given as input to the block instrument. So this is the first input, and the second is home signal normal, means home signal and all reception signal statuses and its controls are normal. Second, that is home signal GNCR. And third is advanced order normal, means LSS status and LSS controls and its statuses are normal, means advanced order GNCR. Third input. Two track circuits after home signal, that means the first track circuit after home and the second controlling track circuit after home, HSAT and HSBT. In case of single line shunting key relay, shunt relay, this is also actually part of block instrument only. So this will not come from station signaling. This is part of block instrument. Apart from these 6 relays, there are 2 other contacts are required as input to the block instrument. They are home control reverse, home signal RR, LSS control reverse, LSS RR. So total 8 inputs means 6 inputs are used to pick up 6 relays in the block instrument, and just 2 contacts are used to directly wired as input to the block instrument. So total 8 are required from station signaling. So there are different interlockings, and first we look at relay interlocking of switch type. As I said, advanced starter RR, in case if it is a switch type panel, the advanced starter RR wiring looks like this. Just if we have a relay there, we just have to wire a contact to block instrument. Just we are using advanced starter RR relay contact, front contact as input. Similarly for home also, and all reception signals like home and calling on. So home RR input is wired as input to block instrument. Typical interface circuits for a single line station, if it is a switch type operation, is just like this. Now we are just seeing a single line station with 2 roads, 1 loop line. We just took upside block only for understanding purpose. So here we can see there is upside home signal RR, there is a downside advanced RR, and output interface, of course, I will discuss it later. So how these interface circuits, how these inputs are wired to block instrument? That is very simple. So first 2 VPRs, they means axial counter inputs. They are wired to the block instrument to pick up AZTR, means axial BPAC relay. So the first track circuit after home signal, here it is a 27 TPR, as you can see here. So the 2 front contacts are wired to pick up home signal ATPR in the block instrument. And the second track circuit after home signal is 1T. And those 2 front contacts are wired to pick up home signal BTPR in the block instrument. These are all relays in the block instrument. So with axial counter relays, AZTR picks up. With first track circuit after home signal, AT picks up. And with the second track circuit after home signal, BT picks up. Similarly, HSGNCR picks up by approving all reception signals, and reception signal status and its controls are normal. It picks up home signal normal, GNCR. So all reception signals we are considering here. Similarly, advanced starter status and its controls are normal. It picks up ASGNCR. Home signal RR and advanced RR, these 2 are just wired as input to block instrument. So there are no relays for these 2 in the block instrument. They are just wired as inputs. LSS on ECR and LSS off ECR just wired for indications on block panel, just to show the status of advanced starter. These 2 relays are wired as just to show the status of advanced starter on block panel. In case of button type, generally we don't directly have a relay, and we will have button relays here, like signal relays and signal route buttons. In case of advanced starter RR, we have to wire advanced starter RR contacts like this, and signal button, cancellation relay, and route button. Similarly, for home signal also, we have to wire reception signals contacts like this: home signal button, calling on button, and route buttons. Here we just considered 3 routes, and of course we have only 3 route buttons here, and cancellation relays. And by proving all these contacts, we are picking up home signal relay, and its contacts are wired as input to the block instrument. So typical interface circuit for single line station button operation, it is quite similar to that of switch type, except here we are just using the button contacts instead of direct relay. Here just we are using button contacts to pick up these home and advanced starter relays. Remaining everything is same. Here also axle counter relays are used to pick up and home signal relays. Home signal track circuits, home RR, advanced RR and indications. So now we will look at the output interface, how outputs are how outputs are interfaced. Sorry. So SSBPAC provides two outputs to station interlocking by processing those 8 inputs. When line clear is obtained, TGT relay picks up. When LSS button is pressed, advanced starter control relay, that means final output relay, picks up. Its two front contacts are wired in the controlling circuit of station LSS DR to let up DECR. So total two outputs are given to station signaling TGT and ASCR, and ASCR two front contacts are wired in the DR circuit, LSS DR circuit of station signaling. So in this picture will give us a detailed view of the system, how the station signaling in input and output in one place we can see here. So block panel is used for sending block requests or commands to the block instrument. Here we can see block vacant means axle counter relay is wired to block instrument to pick up AZTR relay in the block instrument. Home normal relay is wired to block instrument to pick up home GNCR relay, that means home signal GNCR. Similarly, advanced normal relay is wired to advanced starter GNCR to pick up ASGNCR. The true track circuits after home signal are used to pick up home signal ATPR relay and home signal BTPR relay. If it is a double line block vacant, that means axle counter relay, BPS relay, one more relay will be wired to block instrument to pick up AZTR2. So for single line, instead of this AZTR, shunt KR relay will be used. As we can see here, advanced starter RR and home RR contacts are directly wired to the block instrument without picking up any relay in the block instrument. So just they are wired as input to the block directly. So input cards, all these inputs are wired, all these contacts are wired to the block instrument to the input relays, and from these input relays, those inputs are extended to processor card. These CPU cards process the data and produce the output to water, and water card generates output to drive output card 1 and output card 2. So communication card is used for communication purpose or transferring data between devices. An automatic changeover unit is used for communicating with other end block instrument. So this is we have seen for relay interlocking, and in case if it is electronic interlocking, it is slightly different. In case of electronic interlocking, we don't have interface relays, direct relays for GNCR and RRs, and home signal and advanced GNCR and home signal advanced RRs. For this electronic interlocking, EI has to energize 4 relays as additional relays for block instrument. Means you can see here. In case of electronic interlocking, interlocking has to energize 4 relays as additional output relays as input to the block instrument. Because these relays are not available as physical relays, and electronic interlocking, it has to generate these 4 relays as output relays for block instrument. And at the same time, EI needs to receive one input from block instrument, that is ACR input. So EI provides 4 outputs for a block instrument and it receives one input from block instrument. So that is the only change here. In case of electronic interlocking, EI has to generate 4 outputs for block and it takes one input from block instrument. So we can see here 4 outputs are generated and the output of block instrument, that is ACR, has wired as input to the electronic interlocking. So total 4 outputs from EI and one input from block instrument. So typical logics to be used in electronic interlocking to generate or to pick up those relays. Just these are quite similar what we have seen for button type operation. So advanced signal button and its root button are used to pick up advanced order RR. Similarly, advanced order status and it controls or normal proving logic will pick up advanced order GNCR. Similarly, home signal buttons and root buttons are used to pick up home signal RR, and home signal GNCR picks up by proving home signal control and its statuses are all normal. So these are the logics to be used in electronic interlocking to pick up these relays for block instrument. So again, that's what we have shown here. Typical interface circuits for electronic interlocking in case of single line we have shown here. Just we are showing the logics to be used to pick up RRs, ASRR and home signal RR, advanced RR, home GNCR, advanced. Apart from that, the other wiring is same, quite same. So far we have seen, we have covered the block instrument and its features, inputs and outputs, block operations, and interconnection of subsystems, and how it is interfaced with the station signaling. So just now we will have a look at the difference between this block instrument, that is solid state block proving by axial counter, and UFSBI, just for an understanding. It looks like this. If you compare these two, operation wise it is quite similar. There is no change in block operations, but the number of cards used, the number of relays used, as you can see here. In this only we use around 11 PCBs. That is what I have initially told. In this around 14 cards are used because they are having 6 input cards in this. And other change is relays. Here we are using 13 relays on 11 bases. Here we are using 13 relays on 11 bases. Here there are around 32 relays. So that is the change. So this is the basic difference between these two: the number of cards, the number of modular cards used here, and the number of relays used here. So apart from that, block operation is same. As the number of relays are less, it looks very less complex, and of course cards are also less in this. So the wiring portion and all is less, because the block logic is achieved through software here, and here the block logic is achieved through relays. So that is why here we have 32 relays, here we have 13 relays only. So we can say that it is like an electronic interlocking because it has only input and output interface relays, and here the logic is built by relays. So and hence we can call it as a relay interlocking. So it is a kind of electronic interlocking and it is a type of relay interlocking. So again,
Sir, in some latest BPSC installation, there is one EBLM card they are using. So the relays are reduced. The number of relays
okay.
are
In UFSBI also.
Yes, sir. EBLM card, something like that they are using.
Okay. Means in the same spec they are using, sir. Is there any spec?
Actually, that I am not clear, but so in some installations they have made some improvements.
Okay.
So, yes.
Yeah, that is fine, sir. Then.
Okay.
But I don't. Yeah, that. Okay. So that is what just I have covered, and so it looks like this, and block panel is very similar, and both are same actually. So block panel of FSBI and SSBPAC both are same. So but only thing is here block logic is implemented through relays. So here it is implemented through software, so that it reduces the complexity of the system. So as we have less relays. I will just play a 5-minute video of what we have seen now, so that will give a better feel of our block instrument. I will just play a 5 minutes video and I will explain in the background. So what we have covered so far. I will just.